Hello, everyone. We are super excited to have Janice Chen today with us. Janice is a professor at Johns Hopkins University, and I met Janice many years ago, I think in 2013 at Princeton. She was one of my favorite people to go and see movies with, and I think that this talk will be a good explanation of perhaps why, although there were other reasons too, but this talk is a good reason why she's very good at movies. Before we go to the talk, I just want to remind everyone that the Learning Salon is a interdisciplinary forum that, in which we discuss contentions and bridges between artificial and biological learning. We have a very interdisciplinary crowd. Our regulars span from philosophers. Oh, hi, Andy. Andy's here. The span from philosophers to neuroscientists, machine learning folks, psychologists. So if you have a question, especially if you are junior, do not hesitate to ask your clarification question. There are no dumb questions. If you leave your questions in the chat for clarification, somebody might handle it. If there is no response to it, you can put it in the ask a question area. If you have generally any question you want to ask the speaker, put it in the ask a question area that's just below the screen. And then vote on each other's questions. So depending on the flow of the conversations and where we are, we will invite some people on screen to ask their questions. If you prefer that we ask for you, please ask for me so that we know who might be interested in being on screen. Remember that intellectual disagreement is completely welcome. And yes, it's possible. Me and John have intellectual disagreements all the time, and then we laugh later on. It's completely okay to disagree, but we have a very strict code of conduct for respect and absolutely no hate speech. So if there is any kind of hate speech or trolling, then we will be sort of ejected from the meeting. With that, I want to invite everyone to join me in welcoming, obviously behind your own screens, Janice. And we are very excited to hear about memory for narratives and other naturally occurring experiences. Take it away, Janice.
Thanks. Thanks so much for inviting me to this series. I'm really excited to see how things unfold. And I hope that I had to switch laptops at the very last second, so I haven't tested these slides on this laptop, but we'll see what happens. All right. So maybe I should change my screen so that if you need to get my attention, I'll be able to.
Oh, we will just, right. I will just unmute my mic if we needed your attention.
Okay.
Do you know how long about your talk is?
I have 15 minutes of material that I really want to get through, and then a couple other slides. That
okay, cool. Then if it gets too long, I'll just unmute myself, but otherwise just go ahead.
Okay, awesome. All right, so I'm going to be talking about memory for narratives and other things that happen in the world. And I feel like I should say up front that I think I seem to be a little bit different from most of the other speakers I've seen on the list in this series. I'm not a computational model. I don't often think about AI, actually. So my hope here is that I'm going to learn something from you all about whether there's some relevance in my research for improving AI. So can you see my slides changing here? Today, we'll talk about memory. And most of modern research in psychology and memory relies on very simplified stimuli and randomized trials, very minimal paradigms. And experimentalists have to do this in order to control confounds and isolate the specific variables that they want to study. Everyone knows this. But what we learn from simplified experiments is supposed to also remain true in the real world, where things are complicated and messy. And we always hope that our findings will scale up to reality, but we're often secretly afraid that they won't. And that's why I think we sometimes have to do naturalistic experiments, where we put people in situations much closer to the complicated real world. And what we observe there could be surprising. It could point us to places that we wouldn't have gone otherwise. I think that's the value of it. I do think that most scientific experiments should be the clean, elegant design type. This is the agriculture of psychology. It's very productive and necessary. But I advocate for both approaches, and I always hope that they can inform each other. So the type of memory that I study is episodic memory. These are memories or specific episodes or that are tied to the time in which the information was learned. And defining episodic memory usually involves quoting Endel Tulving. He described it as mental time travel. So you kind of send yourself back in time to re-experience that original moment. Another way to describe it is that it's the memory I use when someone asks me, what did you do this morning? Well, I got up, I packed my kids' lunch, I drove her to school, I called a coffee shop from the parking lot and I ordered a coffee and a breakfast sandwich to pick up. And then I tried to drive to the coffee shop, but I got super lost, even though I was just in my own neighborhood because I'm very bad at navigation. And while I was driving, I was actually listening to that Hugo Spears episode of the Learning Salon. So I thought it was kind of appropriate, thinking about how I would be the world's worst taxi driver. So this is one way to think about how we use episodic memory in daily life. Now, episodic memory is typically studied by showing people simple stimuli like words or pictures or pairs of words and pictures, and then later testing to see if they can remember them. An important feature of this kind of memory is that you learn it after one exposure, so no reinforcement is needed. Like my morning, those events only happen one time, and now they're in my memory, maybe forever. I'd like to suggest to you that much of the time when people use their episodic memory in real life, they remember past events and report them as a kind of narrative, just as I reported the story of my morning to you. And in fact, if you read about what literary people think the definition of a narrative is, one important feature is that the events only happen once, and that they happen at a specific time or location, very much like Tulving's definition of episodic memory. So I'm now going to show you what we see in the human brain when people are engaging with realistic stimuli and remembering their experiences in a spontaneous manner. And I started out with this work simply trying to study episodic memory while making the input and output for the human brain more realistic. That's what I wanted, more like daily life experience. And somehow I found that in doing that, all roads seem to lead to narrative. I don't really understand it, but that's what seems to be happening. So I'm going to try to show you. Okay, so how do we study realistic experience in people who are trying to hold very still? The other thing is that we want to scan people's brains while they're having naturalistic experiences and remembering them. And that means that they won't be able to move. So we emulate real world experience using a movie. Movies have dynamic images and sounds. They depict real environments and social situations and emotions. And people really love watching movies, which is helpful for the experiment. And it turns out that when different people watch the same movie, their brain responses become synchronized. And this is a very useful tool for studying the brain. And this is what I mean by synchronized. So if you just take one region of the brain at a time, here I've circled early auditory cortex. Auditory cortex produces a complex response time course while the movie is playing. It's driven by the volume and by different sound textures and other properties of the movie audio. And that complex response time course is the same across different people because everyone is hearing the same complex sound stream. Now, if people are just lying in the scanner listening to nothing, you don't see synchrony across people in auditory cortex. So each part of the brain has its own special response time course, depending on what features of the movie stimulus it cares about. And if you calculate this correlation for every part of the brain, you can make a map of the synchrony across people. So in this technique, one person's brain activity is the model for another person's brain activity. It's a funny kind of model. You don't know exactly what in the stimulus is driving the brain response, but you know how reliable the response is. So something in the stimulus is evoking brain activity in this region, not necessarily like a pulse of activity, but a consistent complex response. And this is how you examine what kinds of stimuli drive responses in any given brain region. And in these kinds of experiments, we find that a non-visual stimulus does not drive visual cortex reliably, and a non-auditory stimulus does not drive auditory cortex reliably, and a non-narrative stimulus does not drive certain areas reliably. I think that sounds kind of weird, so let me unpack why I think that. This is one of several studies, for example, showing that a coherent narrative stimulus seems to be needed to drive reliable responses in a certain set of high-level brain areas. So in this experiment, people are listening to an auditory story, and you see brain activity synchronized across subjects in all of the colored areas in this map. And then they scramble the story coarsely. So you break the story into paragraphs and shuffle them, and then play people this paragraph scrambled story. And now you're only going to see synchronized activity in the red, yellow, and green areas, not in blue. So the paragraph scrambling broke the narrative of the story. And you get the other colors in this map by scrambling the story progressively in finer and finer temporal pieces. These brain areas respond to narratives presented in any modality, right? So it doesn't matter if it's an audiovisual movie, auditory story, written story, silent movie. And not only that, the responses seem to track the story, not the modality. So a lot of these experiments reviewed here and in other places, in a lot of these experiments, the same story is presented using different modalities, like using words or using pictures. And those two different modalities will elicit synchronous activity in these brain areas across people, despite the fact that they're presented in very different formats. So now a lot of you recognize these brain areas. These are the same areas that are typically active during episodic retrieval. They're called the core recollection network. And they also overlap with the famous default mode network, which are co-active when people are resting and thinking freely about whatever they want to. So there's a kind of convergence here that is a mystery. What do narratives and episodic retrieval and spontaneous mind wandering all have in common? So what is this network doing? I'm going to show you an experiment now where we try to understand this a bit better. I'm not saying I'm going to answer the question, but we're trying to get more information about it. So this is the paper that I included for this talk. So in this study, we show people a movie. It's about 50 minutes long, and they watch it in the scanner. They watch the entire thing. I'm not going to play the clip, but it's Sherlock's, BBC's Sherlock, first episode. And then after they watch this movie, the people are asked to retell the entire story from start to finish using their own words. And they don't get any other guidance than that. So they just start talking, and they talk and they talk. And they go for anywhere from 10 to 40 minutes to describe this 50-minute movie. Now, the behavior is quite rich. So here's a way to look at the behavior of one person. Each one of these blocks is a scene in a movie, and you can see the time during movie viewing on the y-axis and the time during recall on the x-axis. So the fact that you have these blocks kind of following along the diagonal is telling you that this person is recalling the scenes in roughly the correct chronological order. This is actually the full text transcript of what somebody said during this experiment. And it's we have about 2,600 words on average. And if you see blocks floating off of the diagonal like this, it means they were recalled out of order. Well, it doesn't necessarily mean that they thought that scene happened in the wrong place. It could be that they forgot to retrieve it. They forgot to talk about it at the correct time, and later they remember it. You can put everybody on one plot like this. So now each little line is the diagonal of one of those boxes from the left, and you see the variability. But everybody is forming a kind of line. So there's a quite good chronological recall here. And the completeness of recall is quite good. It surprised us. It surprises the people too, actually. They don't think they're going to be able to do as well as they do. All right, so remember what I told you about synchrony of time courses across people. It turns out that you can also do this with the local spatial patterns in each brain region. So for these analyses, we split the movie into scenes. We make an average spatial activity pattern for each scene, for each brain region. And then we correlate that pattern across subjects, just as we did with the time courses. But here we're going scene by scene. And the goal is to test whether each scene has a different pattern of activity from other scenes, and whether that pattern is similar across people. So what's nice about this is that you can do it during the movie, but you can also do it during recall when people are not experiencing the same stimulus. They're remembering the same scene and they're talking about it freely, but they're not temporally synchronized. So you wouldn't be able to do a time course synchrony analysis.
Janice, Janice, I'm sorry to interrupt, but just to say, when you say scene, is it a silent scene, or is there also narrative in the movie as well as images? Is it both or not? I can't.
It can be everything. Yeah, we have a lot of different movies that we've done this in. Some are silent, some have music, sometimes there's talking. There's not usually like a narrator talking in the background, like telling the story. But we have all kinds of things. So I'm glossing over a lot about like what a scene is because in a way we don't know.
So scene doesn't mean just visual.
No, it means an event boundary. So it means like Sherlock at the coffee shop, like talking to Watson, and then there's like a director's cut, and it's like now they're getting into the taxi. That's a scene boundary.
Thank you.
So sometimes these scenes will be up to a minute long, actually.
So Janice, do you maybe want to remind us, did you use MTurk participants to code the scenes, or did the experimenters code the scenes?
We usually do, for this study, we had it done in lab, and we just had a couple of people segment and then look at agreement. That's typically how you do this, but you can go all the way to collecting 200 subjects on MTurk and looking at the agreement. Yeah. The main reason for needing to divide the movie into scenes is so that you can find the corresponding scenes during recall. Otherwise, you can do this kind of pattern analysis at the TR level, and it's fine. Okay, so the first interesting finding here is that local brain patterns are reactivated when people are verbally recalling the movie. So here we've done this in a searchlight across the brain. So you look at every little local piece of the brain, and these are the regions where a similar pattern reappears when you are remembering a certain scene in the movie. And those scenes also have a different pattern from each other. The second interesting thing here is that those local patterns are also similar across people when they're remembering the same event. So it's not only your own kind of special experience and then your memory of that. Your memory and your description of that coffee shop scene, whatever words you choose to describe it in, there's also a similar brain activity pattern in another person remembering that same scene. So there's some kind of consistency here, that reliability that we talked about. And we often frame this as a classification analysis. So on the left, this bar is the classification accuracy for individual scenes during movie viewing across subjects. So your chance level there is 1/50. And the performance, you're getting this correct about 40% of the time. And it's about half that good during recall, which I think is still pretty good. So basically, that's how discriminable the scenes are from each other, and how well you can classify them across brains. And this is the spatial scale of those local activity patterns. So here, if you just look at B and C, rows B and C, you're looking at the activity of individual scenes on the columns and two independent groups of subjects in rows B and C. So there you can see how, as you progress from scene to scene, the patterns change, but they're similar between the two independent groups. And by averaging across a lot of people there, I think we're showing you what spatial scale of activity is driving this similarity. You know, when you align people's brains with each other, they can only be so well aligned because they're really not that identical, right? So there's some kind of relatively coarse spatial activity pattern, but it does provide us with enough power to individuate different scenes of the movie. Okay, and this is a public data set that you can have a look at. I'm very proud of the fact that a lot of people have gone on to analyze this for lots and lots of different reasons. And okay, so here we have the different things that I've showed you. We have a network of brain regions that seems to show reactivation during episodic retrieval. It is functionally connected during rest. It it seems that synchrony across subjects requires a narrative, and the patterns are correlated scene by scene across subjects when they're remembering a movie. So the million-dollar question here is, what is the content of thought that's represented in the activity patterns of these regions? A lot of people are quite interested in this now, I think. And there's an idea out here that's increasingly popular. So the idea is that the default mode network activity patterns carry information about situation models. These are mental representations of the relationships between entities, actions, and outcomes, the story within a scene. A situation model is like a schema that specifies the gist of the spatial, temporal, and causal relationships that apply within a particular context. And these ideas are rooted in ideas from the narrative comprehension literature decades earlier. Now, I use this quote from Ranganathan and Ritchie all the time, and partly I use it because I think it leaves the door open an appropriate amount. The field does not have a consensus on what information is carried in these activity patterns. And it's kind of imprecise right now. I think we have to acknowledge that. For me, at least, the reliability of the signal across brains and the fact that it's specific to individual moments of experience and reactivated when we remember those experiences, this gives me confidence that there's some kind of strong signal there that's driven by the narrative stimulus. So I think that there's an opportunity to deconstruct it. Okay, so how do we study realistic experience? We use movies and stories as a proxy for real world experience. And as an important class of stimuli in their own right. They're not only emulating the real world, they're a kind of stimulus that we engage with by choice all the time. And here I'm quoting Gordon Bauer, consuming stories has strong face validity as a task humans frequently perform with the goal of remembering. It is not the least bit artificial. So I think I'm going to spend 1 minute on the last couple slides here, because I just want to give you a flavor of some of the other experiments that we're doing to follow up on this work.
You can take your time. You don't need to run.
Yeah, I'm okay.
Yeah, of course. Take your time.
So one way to think about using narratives to study memory is that memory experiments, episodic memory experiments, usually have an encoding phase and a retrieval phase. You study or learn or are exposed to some stuff, and then you have to be tested on it somehow. And you can make either the encoding or the retrieval phase more or less narrative-like. So in this little cartoon that we drew, you have less narrative-like encoding on the x-axis and more and less narrative-like retrieval on the y-axis. So if you look down at the bottom left corner, this is an experiment where you study a random list of words and then you perform a recognition memory test where you just look at one word at a time and say, is it old or new? So this is a quite simplified paradigm. It's not very narrative-like. On the upper right, you have something more like the experiment I showed you, where you watch a movie, like a full-on story, and then your test is also very narrative. You retell the story of what you just saw. And then you have these other quadrants of the graph. So in the lower right, you watch a movie, but then you take a simplified test that's probing specific things, maybe true or false test about events in the movie. I think I also do that kind of experiment. And then in the upper left, you have this funny box where you didn't find any experiments like this, actually. So you may have a non-narrative input, imagine a list of words or kind of random stuff. And then at the time of retrieval, you have to turn it into a narrative. The more that we thought about this, the more we thought maybe autobiographical memory is kind of in this category. It doesn't necessarily have a narrative structure on the encoding side. You just kind of move around the world doing your stuff, right? But when you have to remember your life, you may turn it into a narrative for various reasons, either to help yourself remember it or to fit it into your picture of who you are. Or maybe that's just a very good way to communicate it to somebody else. So I got more and more interested in autobiographical memory by looking at this diagram. So one of the, not about autobiographical memory, but one of the lines of research that we're pursuing in my lab is about how the structure of a narrative could affect memory. So in this experiment, we take movies and we turn them into graphs. So every event in the movie, every movie scene becomes a node in a graph. And the connections, the edges between nodes can be defined in various ways. Here, they're defined by semantic similarity that we calculate from sentence embeddings. We can talk about this later if you're interested in the method. And the upshot is that you can calculate the centrality of events. It just means that an event has high centrality if it's connected to or similar to a lot of other events, right? Event centrality turns out to predict a lot of things about memory. So we can predict recall behavior, like the probability that an event will be recalled across the group. And it also predicts inter-subject synchrony in some of our brain regions of interest within the default network. And it predicts hippocampal offset responses, which have been shown to be related to memory consolidation.
Hey, Janice, can you just clarify, when you say semantic similarity, are you using the individual's semantic description of the scene?
Here we're using external annotations of the movies. Okay. So not the people who are actually having their brains scanned, although you can do this based on their recall transcript too.
Okay, thank you.
Yeah. It's a way of calculating semantic similarity that is just fast, basically. I would be happy to do this with human judgments of all of the pairwise semantic similarities between all of the scenes as well.
And Janice, in a similar vein, in the fMRI, are you looking at what events are similar in the fMRI similarity of events separately and correlating it with the annotation similarity, or you're just looking at the similarity of everything else to the particular ones that were annotated by others as being central?
I got a little lost in your question there, sorry.
In the fMRI similarity between the fMRI of different events, there could be that I'm recalling some event because of my narrative understanding of the movie. And so my individual recall, my individual fMRI similarity to some event might be more than the event that was labeled by others as central, right? So it could be that individual variability in what becomes central in their fMRI pattern similarity across events might have a different kind of graph than the one that has been annotated, and that might predict their comprehension of the narrative.
Right, so so centrality here is determined strictly from the stimulus.
I see, right? Not separately from the fMRI. Got it.
Right. Yeah, we have done the kind of RSA version of this that I think you're hinting at, where you also create a similarity matrix of all of the fMRI patterns of the events within each person.
Exactly.
And yeah, so then you're doing a correlation of like this triangle, this lower triangle of the matrix with the same lower triangle created from the fMRI pattern. Yeah.
That's right. So honestly, I thought that's what you did.
Yeah, you can do that as well, and you'll see a kind of similar set of regions that where those two triangles will be similar, right? You'll see some of these default network regions, but this particular analysis is about the centrality of the events that's calculated from the stimulus itself.
Right. I guess my comment was that if there is the individual variability in the fMRI versus your expected semantic centrality could predict people's narrative comprehension.
Yeah, I guess you could ask whether if you calculated the semantic similarity matrix from their recall transcript, would their own transcripts be a better predictor of their own fMRI similarity matrix, right?
I think that would be the case. But in this case, the idea is that even if you didn't have access to transcripts, but only to their brain data, you could, based on the similarity and the graph that emerges from their RSA, you could predict what part of the narrative they might be deviating from the actual narrative comprehension that majority of people have.
Anyway. Yeah. So, yeah, let's talk about it. Let's talk about it a little more. At the end of this talk. So the one other thing I wanted to say about this study was that in thinking about narrative, it's become more and more clear how important causal relationships are in a narrative. And so we also have a graph defined from causal relationships and causal centrality. And you see some of the same things. So the graphs look different. They're much sparser and they're more like a chain. Like the narrative basically is like a chain of causal relationships. It still predicts recall quite well, the centrality defined from causal relationships. It still has a similar pattern in the hippocampus, but we don't see that inter-subject correlation of the event patterns anymore. And so this is kind of puzzling to me because it seems like the causal relationships are so important for the narrative, but we have yet to kind of find the same neural correlates that we do when we're looking at semantic similarity. So this is a mystery. And two other directions that we're taking to try to capture even more of reality in these kinds of studies. So one thing that a narrative is definitely missing in terms of its similarity to your daily life is that you don't make choices in a narrative, right? You get fed this kind of series of events, and then it may be very engaging, but you don't get to direct it at all. And in your normal life, you actually get to like turn your head and look around and choose where you're going to get information from. So we're now running experiments where we let people control the narrative. If you have ever read these kinds of books where you choose your own adventure, that's essentially what we're doing here. These are text adventures. So you read along, for a paragraph or two, and then you get to make a choice about which direction the story is going to go. And so you now have this kind of complex tree of decisions that you can make and where you're going to end up. And, the idea is that if we allow people to engage with narratives in a more active way like this, to what extent are we still going to see some of the same effects of narrative structure on memory and on brain activity? And to what extent are we going to see something different? And finally, another set of experiments that we're planning is trying to essentially do autobiographical memory experiments, but all in the scanner. So it's always been a bit frustrating to me that imaging experiments for autobiographical memory, you can never get the brain data from encoding because people are out in the world. But I thought, during the pandemic, a lot of life is on the computer. So we actually started thinking about this in a class I was teaching where Hung Mili was kind of helping me out with some of this. And we have people doing common internet activities, basically browsing the web, looking for stuff. We give them a couple of simple tasks to complete, but they are largely guiding their own experience here. We screen record them. And then we have them perform long narrated spoken recall, the same as we do after a movie. And so here, not only do we add back in the element of choice and kind of foraging in your environment, but the input isn't a narrative, right? It's in that upper left box of the diagram that I was talking about. The input is not a narrative, but when people remember it and retell it, they may try to narrativize it, and I'm very interested in that process. Okay, last slide here. I want to point to this amazing open data set that has come out recently from Sam Nastase and many others who contributed to collecting this data. So anybody who wants to go and look at fMRI data while people are listening to narratives, there's this huge open data set with all kinds of nice pre-processing and quality control. And I encourage you to go and check that out. Okay. And I want to thank all of the people who contributed to the work that I presented here today. And I'm happy and excited to get started with the discussion.
Great talk. Thank you so much for that. John, do we allow Jovo to go first this time? Because you and I usually go first.
Absolutely.
Perfect.
I was just about to suggest that I'm sorry, that Joe go first.
What were you going to suggest?
I'm joking.
Thanks. So yeah, that was a really fun talk. I remember 5 years ago when I first saw that paper come out. I just thought it was so cool. Like, the first few slides where you talked about this difference between like a garden and the wilderness, and how people have really focused on the garden, and that there's real value in the wilderness. Not necessarily doing all experiments there, but we should, peer in there sometimes and just see what's going on, and then try to relate that back to the really controlled experiments. I thought it was a really beautiful analogy and a deep insight. And it was one of the first papers I ever saw, for sure, which did it so nicely and clearly. Like, it's hard, I would imagine, having never done these experiments, to actually design a really carefully controlled wilderness experiment, because it's almost like counterintuitive, and it's kind of the opposite of what we kind of normally do. So I just thought it was a cool idea and a really beautiful implementation of it.
Yeah, thanks. I just wanted to say that when I first arrived at Princeton, I also found myself like totally in culture shock when I came to Uri's lab, and that did not look like science to me, but I really, really wanted to do it. And it took a long time to kind of like wrap my head around those kinds of experiments.
Yeah. So, as you mentioned in the beginning, like this whole salon, as Ida so eloquently puts in the beginning of each one, we're trying to understand the relationship between natural and artificial intelligence. And so, you said something early, like you're not sure, but I want to kind of dig a little bit deeper with you. Like, what do you think that tells us, these experiments tell us about human intelligence in a ways that we could possibly translate them? Because I think they're deeply insightful, but I don't know how to like put it into the general narrative of intelligence and learning. So maybe you can help do that.
I mean, I think that the question I keep returning to in this talk and in my research is, what is the information? This kind of abstract information that's represented in this network of high-level brain areas, in the default network, or whatever you want to call it. It has a million names. It seems to be kind of modality independent, almost, maybe not completely independent, but you can tell the same story using words or using pictures, presumably like using hand gestures, or if you can get the same story across, then you can get a consistent pattern of brain activity in these regions. And so if that is kind of the digested version of reality, like everything that gets funneled in through your senses may converge on a abstract representation like that, something that's about the situation that you're in, the agents that are there, the location, maybe the goals of the agents, and probably quite a number of other features and dimensions. That seems to me quite important to understand if you want to figure out how people think, right? That there may be a kind of hierarchy of different elements that stack together and add up to a representation that is fairly simple, relative to all of the possible pieces of sensory input at the bottom of that hierarchy. And the other part of that is in being able to tell somebody else and communicate that information. It does make sense that it would have to be something pretty compact and efficient, right? That we can use language to then tell somebody else about your morning, right? And the stuff that happened to you, and they generate a picture in their mind that is not too far off from what you experienced. So being able to kind of understand what those features are in the brain activity up there, I think is the motivating, the motivator for the work.
That's a great point, and maybe to just dig a little deeper into that. So it seems like there needs to be some kind of an abstraction that could be from any sort of sensory region, but there is some part of the hierarchical abstraction that is at that point not dependent on what modality you receive that information from, but what kind of model of the situation or the agent or your environment you made. And what do you think, what else do you think is going on there? Because memory researchers sometimes stop there. It stops at abstract associations, but you know, they need to be compositional, they need to be compressed somewhere, they need to be reinstated in other image areas, they need to be reinstated in other modalities if needed, if I needed to turn the abstract again into an actual image. What do you think about those, especially compression? What do you think about the ways in which the relations and let's call it the, well, it's compositionality, but there is a logic, there is a language to it. It's not just anything that gets attached to anything. What do you think of those? We don't often study them in memory, but I think that if we want to link these findings into AI that's more human-like, that might be important to figure out.
Well, so you're talking about the compression aspect of it.
Well,
so
compression and composition.
Yeah, so composition, I guess, is the relevant here in the sense that there's going to be some features, maybe not all of them are necessary and not all of them are sufficient. Maybe they're even additive, but there's going to be some set of features or dimensions that get encoded in the brain activity patterns here, and maybe we can discover what those are.
Oh,
right?
no, what I meant was that you can, I meant compositionality, like a language. You can compose different abstract things together to draw new conclusions or infer a meaning out of the sort of the different parts, different pieces that you saw together, which happens in fact in a lot of narrative and movies. You're told some kind of story from different perspectives or different pieces of something, and you need to construct the narrative at the end. So there seems to be a language to these kinds of narrative constructions in which your memory needs to be composed, put together with some kind of a grammar, with some kind of a logic, so that it gives rise to the meaning that needs to be
yeah, I agree with that. There are definitely rules. And I guess you can think about that like within a scene, and also in the way that the scenes link together in a narrative, how the events link together, right? So if it may be that it's helpful to have agents, and it's helpful for the agents to be in locations, and locations can't be in agents, for example, right? There's going to be some kind of laws that govern what you commonly find in these scenes. And in a narrative, the scenes often need to have causal relationships too, and people are looking for that when they perceive them and when they reconstruct them in memory, right? So part of what you do when you remember your morning or your life is that you're trying to pick out the thread of events that are worth remembering, or maybe worth telling another person. And you know, you could remember the same set of experiences, like your same morning, you could have a different memory of it if you have a different goal in remembering, I suppose. So I think that I agree with you that there are rules like this that maybe also need to be written down in addition to the features or dimensions themselves. It's not going to be like a bag of features, right?
Thanks, Ada, for following up. First of all, I thought it was a really interesting question. Also, just it's fun when we're all kind of talking about stuff together rather than sequentially asking questions. So I actually want to build on what Ada was saying. And Janice, you talked a little bit about how it's about kind of the representations in the brain. And as lots of us know, in machine learning, there's lots of effort in learning representations. But typically in machine learning, not always, the representations we learned are like Euclidean feature vectors. And the way you described the representations, it was a graph, right? There was I wasn't sure if you were saying that was what you thought the internal representation was, or that was just a convenient way of thinking about it. But I think it's an intriguing possibility that our internal representation has more structure and more elaborate topology than Euclidean can, just like Ida was talking about with language. There's a topology to the representation that enables all sorts of things. Like you add one edge to a graph of knowledge, and now there's two different communities that weren't connected to one another at all, and now they are. And you can't have that kind of thing with Euclidean representations. There's no such way to do that. So I guess I wonder if you think about the structure of the representations in our brains and whether, like, what space you think they live in, and is there some structure to it beyond just a smooth Euclidean flat everywhere space?
I don't know if I have a good answer to that question. The graph that I was showing was treating each event in the narrative as a node and trying to see whether we could kind of succinctly capture some of the properties of different narratives. So I guess it's, I guess I do think that maybe there are families of different types of narratives, right? There's like a bigger space that all of these graphs can live in. But I'm not sure that that is what you actually were asking about. Are you talking about are you thinking of graphs where the individual nodes are events from a series of events in a narrative, or are you thinking about the kind of possible features within a single event, like an actor and a scene and the different objects in the scene and its goals? I think those are different depictions.
I guess I'm agnostic to those in the sense of, my question is really about, if we have representations, they're useful insofar as we can manipulate them. And so they should live in a space of representations that enable different kinds of manipulations. And we get to choose what space we are talking about when we talk about them. And so if we choose the space of graphs, it's richer than the space of vectors in various ways. It enables alternate kinds of computations that we can use if we have that. And so I just think your work kind of alludes to that possibility in a really nice way.
Yeah, I mean, it's a very interesting comment, but I'm afraid I don't have much to elaborate on in thinking about it. I'm not sure that I've thought about it in quite that way. I mean, we certainly in the analyses of, you know, fMRI voxel activity patterns, where we're just working with vectors and correlations between vectors or distances between vectors. We're not yet trying to model like individual elements of the situation model, right? But maybe that's where it should go. Yeah.
I don't know. It's fun to think about anyway.
Yeah.
Okay, Ida, John?
John, go ahead. But before that, I just want to say that Marina in the chat said that she likes Joe's question, and she says that it seems like what we want is variables, not spaces. And she links a paper by Rebecca Sachs in TICS called Seeing Other Minds in 3D. So I'm not sure what they have in mind, but I guess they wanted to make this comment with regards to Joe's comment. John, go ahead.
Hi. I have to say, I find these results sort of fascinating and spooky in the best possible way. I mean, I was thinking to myself, listening to you, that it really feels to me, and sort of the things we've been discussing, and that you're really onto something, right? There's something deep here. It's startling, actually. And I absolutely get what you're saying when you say what the key thing is that you keep coming back to, which is what on earth is there, right? Right, and it comes down to, you know, a lot of cross-disciplinary literature on story and narrative, and what is it about narrative versus, you know, juxtaposed images, or just having a camera left on in the park and things happen, but there was no story imposed on it. I mean, you could yourself, and you know, and you know, if you listen to literature classes when stories are discussed or films, is, well, what was it about? What was the meaning? What were they trying to convey, right? What were they getting at, right? And what you seem to have done in your experiment, if I'm understanding your interest in what's at the heart of this, is that people watch, presumably it could happen with a silent movie, and then they could verbally retrieve from whatever happened during the movie, and then give a verbal version of it. Okay. Now that is absolutely the Chomskyan argument par excellence, right? Which is you absorbed something visual and had meaning in it, and then you turned that meaning into a verbal description that could be sent to another person. And then very interestingly, the activation from this verbal transporting of this meaning that wasn't initially verbal activates a similar region as the original meaning area. I mean, that is bloody deep, that result, right? In other words,
we had that experiment actually that I can tell you more about it.
Aha, fantastic. So in other words, it's really about meaning and its translation and transportation, and then reconversion into something that looks like the nonverbal version that started the process to begin with. So that's just deep and beautiful, right? I mean, it's really, what I was wondering is why you focus more on the memory part than the narrative meaning part. In other words, in a sense, and the reason I say that is sometimes you could imagine, and I think you probably know this far better than I, and there are other people in the chat also who, about, you know, the unreliability of memory, right? That at some point, the narrative that you tell about what happened to you begins to uncouple through retelling increasingly from what actually happened. And it would be very interesting to me if you were to be able to image someone and go, look, forget your narrative of what you thought happened. Can you try and remember what actually happened, right? And what I wonder about that is, do you think that sometimes narratives are a substitute for what actually happened? In other words, by being able to string together a story, you can fictionalize what actually really happened, because it's easier to remember it in a certain order because meaning helps you keep it in your head. Versus the meaningless sequence, which might, without having this meaning imposed on it, would be harder to remember. So one is, I think it's very, very deep about what representation is, and a meaning-based representation. And I think you're really onto something profound. But I also wonder whether sometimes the narrative can be a substitute for what actually happened, because it's easier to remember a story than the actual sequence of events. So I was wondering what you had to say about that.
I totally agree. And maybe a question is, how much do you really remember of anything? And how much are you just recreating based on the very sparse story that you were able to tell yourself about the morning? So I do think that we do a lot of regeneration, right? And I'm not even sure how you would really differentiate between having a kind of code that is stored somewhere that allows you to recreate in some kind of mid-level or high-level visual cortex a scene that you saw earlier. How is that like different from actually reactivating the pattern that was originally there? Maybe they're like not at all different. Maybe they're exactly the same thing. And that is what memory is. Not putting yourself back into the same state because you somehow travel there, but being able to regenerate the same state that you were in at the time of the original experience.
Because there are moments in movies, right, Janice, where somebody will be where the person will have been at an event and a thing, and then they're asked by the detective, is there anything else out of the ordinary that you can recall that wasn't? You go, oh, now that I think about it, all the windows on the first floor across the street were open, right? So there's a sudden, so in other words, there seems to be a difference between being able to sort of replay what actually was going on, which wasn't inserted into a narrative, versus, as you're implying, at the moment of watching the movie, what you're actually putting in your head is the narrative you're constructed in real time of the movie, rather than the incidental things that might be happening in the, as Roland Barthes called, sort of the punctum, the periphery of the image, right? So I'm finding myself in tension between, are there things that are being remembered but not noticed until pushed? How many deck chairs were there on the balcony during that scene, versus did they have a fight while sitting in the deck chairs? I'm just wondering, do you care about what was actually recorded versus what was already being turned into narrative?
I think that you are incidentally encoding a ton of information. I don't think there's any dispute about that. You don't have to narrativize in order to remember. Now, what you said about having a narrative making it easier to remember is absolutely true. And because narratives often draw on familiar experiences and tropes and schemas, that can be very helpful. It's something that you're really familiar with, right? So we see examples of this in the movie Recall. So one demo that I play sometimes is, directors play little tricks on you. They don't always tell you everything up front. Sometimes they put things a little bit out of order. There's this scene where Sherlock is looking out the window and he sees cop cars pulling up, and then he kind of infers something about what's going on, and he says it aloud. And when people retell this scene, they always put it in logical order. They tell it in the order of events that you would need in order to understand that one event caused the next. He saw the cop cars, that's why he figured out what was going on, and then he says it. If you go back and watch the original scene, it's not shown in that order.
Precisely,
right? So
precisely,
yeah.
right.
So people tell it, people make sense of what they saw, and they will be able to remember it better if there's a causal chain. Right? That's
So do you
often,
think,
I think what we're trying to get out of our world.
So do you think that activation that you're seeing, which shows considerable overlap between what you're watching and then what you're saying, do you think that region is weighted more towards narrative meaning or towards incidental memory of what you watched during the movie, given the similarity that it has when you tell the narrative? Does that mean to you that it's weighted more towards its narrative layering on top versus the raw thing that happened, given the similarity that you've so interestingly shown when they then recall it? Does that imply, and I'm not absolutely sure in my head whether it does, that you're seeing more meaning-laden narrative type stuff there versus the actual stuff that was laid down because it overlaps so much with the narrative? Is that something that follows, or what's your view on that?
I'm not sure that, I'm not sure how much traction we have on that. I mean, the stuff that we measure there, our best way to measure it is to look at the reliability across people. So whatever signal is there is something that everybody understood that aspect of the scene in the same way.
That's
right?
what I'm asking. That's exactly what I'm asking. Does it imply
that's what it implies. Yeah.
Yeah, that's fascinating, right?
Yeah. So we did do the analysis where you look at the reactivation within one person. So my actual brain during watching the movie and my own recall, and you try to compare that to the strength of the similarity between somebody else watching that movie scene and my recall, right? So is there any difference there? And it's a very, you can't totally answer the question that way, because my brain is just more similar to my brain half an hour later, like anatomically, than it is to another person's brain. But we were very surprised at how little difference there was. Let's say that. So going into it, I would have thought that my own memory of my own real experience would be, those would be a better match than my recall compared to somebody else watching the movie. But it was actually pretty similar.
Yeah, that is profound.
So that leads more towards what you're suggesting, that the representations in those regions are more on the kind of they're on the like coarse meaning side, I guess you could say.
Right.
Something that most people share their understanding of what's going on, and less on the kind of little details that may not fit with the ongoing narrative.
Yeah, that's exactly what I was inferring, and that is cool, really cool. Yeah, thank you. It blows my mind a little bit, actually.
We have this other experiment I want to mention since it is related to this. So this is an experiment led by Asya Zadbud. We did this at Princeton in Uri Hassan's lab. This is in cerebral cortex. And there, she had people watching the movie, and then they listened to the recall of one person, right? One of the speakers from this experiment that I showed, actually. Those people listening, you have one group that's watching the movie and one group that's listening to the recall, but the people listening have never seen the movie. So they're just naively listening to a description of the movie, of one person's report of the movie, never having seen it before. And now you can take those listeners, those naive listeners, and compare their brain activity to the people who actually were watching the movie. And see, so this is like, they call it a kind of cycle of communication. So some people watch the movie, then they talk about it, other people listen to that, and then you see the brain patterns, scene by scene, specific brain patterns can reappear in the brains of people who have never seen the movie. It's surprisingly strong. So the unpublished part of that data is that we also had a group of people who did watch the movie. And it was still like people who have not seen the movie compared to people who have seen the movie, there is surprisingly little difference.
Is that published?
The Zadbud, the naive listening part is published, but not the listeners part.
so not the imaging on the people who you looked to who had not seen the movie.
No, that part is published.
Oh, wow. Well, listen, I mean, it's actually brilliant, deep stuff. I can't, it's really wonderful. I mean, I'm going to have to think about it. I mean, you're at Hopkins. I have no excuse. We should talk. I think it's just wonderful. Thank you very much.
Thank you. I really, I'm interested to hear what people think about the kind of causal chain and how causality is important in narratives. This is the part of it that, like, we don't have much of a handle on in the brain activity, and I'm trying to figure out like how causal relationships can be so important in a narrative, but we don't really like see brain activity that tracks with them, and like how we might be able to get to it. So if anybody like has ideas about that,
I have a dumb idea I just thought of right now, which I can say. Curious what you think. So I can imagine constructing like a causal narrative Necker cube story where the causal chain could go one of two ways, and it's totally ambiguous from watching or listening to the narrative which one it was. And so like half the people would see it one way, the other half the people would see it the other way. And then that could allow you maybe to tease out whether this causal narrative that people have is doing the work of changing their internal representation dramatically or not.
Yeah.
Does that get at what you were saying?
I think there's a paper that's kind of reminding me of, it's not about causality specifically, but it's about these interpretations. I mean, so this is Yeshurun in Psych Science 2017. It's called Same Story, Different Story. And there you have exactly the same story that all of the subjects are listening to, but half of the people have been given a different backstory, basically, about what's going on. And so as they listen like to each event, they have a different interpretation of what the relationship of the characters is to each other, what they might be thinking, why they're doing the things that they're doing. And there, there would have to be a different, I don't know about two totally different causal chains, but it's true that in a setup like that, you would have to, I guess the causal graphs that we build would actually have to be different, right? So maybe we can take a look at that data and see. One of the problems that we have with analyzing causal event structures is that when it's just a chain, there just isn't a lot of. It's just a very sparse matrix that you're working with, right? So it's just like cells along the diagonal, whereas the semantic relationships, you get to have a value in like every cell. So it may be that we just are missing a lot because the prediction matrices are really sparse. And if we could find stories that have a lot more causal complexity, maybe that would help. But we usually use popular movies and stories because they're engaging stories that are easy to understand tend to not have a very complex causal structure.
We might need to make some of our own movies.
Yeah.
So I could continue asking a question I started asking you, but I think that is a kind of a boring question because it's clear to me that could be an application and it could be real fun. So I'm just going to say it very short and go to a more interesting question. So what I was asking during your talk was whether if you imagine 3 different graphs that are constructed. One is from independent annotators. One is from my own recall. And one graph is based on the similarity in my RSA. So you have identified that based on my brain data, these are the central events. Based on what I said to you, these are my central events. Based on what everybody else constructed, these are the central events, right?
Yeah, I like that. Yeah.
So that's what I had in mind. And what I was suggesting is that if you compare the brain data graphs versus the independently annotated graph, then without even seeing what I said about what I remember, you could predict which points I would understand the story differently. And potentially, if those central parts played some kind of causal role, you could see whether I'm going to make the inference of the story. Let's say, for instance, it's a crime story, or let's say it's something like Memento, or let's say it's something like, do you remember the strange movie that Bo showed at one of Uri's meetings?
Yeah, I was thinking about that before.
Yeah, I don't remember. What is the name of that movie? I've never managed to watch it, actually.
I don't remember either.
Anyway, so that movie, which movies like that, right, where you need to make some kind of an inference. I think that using, or something else that has a causal chain, like a sci-fi, where you need to infer some causal relationships in a different world, which is different from ours, in order to understand the story. Either way, comparing these 3 different graphs is going to enable you to predict the neural structure just based on the narrative graph. But even more interestingly, just by looking at somebody's brain and comparing that graph to the annotated graph, figuring out which parts of the narrative they might misunderstand or misremember.
Yeah, I like that.
I was saying.
Yeah. I think that in the study I showed that Hongmei Li there's a preprint out. We use pretty short movies, and I know that she has looked at centrality calculated both from the external annotators and from individual people's recall, and they're pretty similar. So I think I like your idea. I think it would require a much longer and more complex narrative in order to have enough deviations, basically, of a person's retelling, I guess, in order for the recall and the annotation to actually generate substantially different centrality.
Yeah, you would need a story like the movie that Bo showed us, movies that are like Prestige or these kinds of movies that are different. If you look away for a moment, you might not get what's going on.
I was thinking about that movie right before, because I was remembering how good Ida is at watching movies. It was actually quite puzzling to me. This was a movie clip that is supposed to be so confusing that it generates a lot of discussion and people can't figure out what's going on. And Ida like guessed what was happening immediately. That showed me that I didn't know how to watch movies.
I mean, there was a child, and the child looked at Nicole Kidman in a way, and it was obvious to me that obviously the child is, haunted by somebody else, and some grown-up who has a relationship to Nicole is in this child, and everybody looked at me like I'm crazy. And they both said, "Yep, that's the story."
Yep.
I had a friend like that who was also uncannily good at going to movies. I remember going with a bunch of friends to see Mulholland Drive, and we were all scratching our heads, going, "What's going on there?" And he just effortlessly went, "I know exactly what's happening." Extremely annoying.
John, we should go to movies together because I have no idea what's going on.
This is one of the things that I miss. I almost mourn in my life. So Janice and I used to go to the Princeton Garden Theater and used to just watch movies and take a walk. And she really likes a lot of like butter in her popcorn, for instance. Like there's these kinds of things that you learn about people. And I really missed it. After Janice left, it was such a void for me. I watched movies with other people, but it wasn't the same.
Yeah, I miss those too.
The other thing that I wanted to say is that people with various kinds of mental illnesses have different perception of movies, and they also have different ways of relating to memories. This is especially the case when it comes to narratives. I recently read this book that really sort of made me think about how we are thinking about memory and how much we could do more in terms of the notion of narrative and autobiographical memory, especially. There is this approach apparently to PTSD therapy called internal family systems. And they have this idea that a person has a lot of different parts. And some of these parts are protecting the person from some parts in their past when something very bad happened. And usually in people's lives, it's not just one thing. There's a bunch of things that have happened. And there are these protective parts. And sometimes when you are talking to a person, it's not the person that's talking to you. It's the protective part that's in that part of the memory stuck there. And if something triggers and activates that memory, then that protective part is going to talk to you and not the person. So the entire sort of infrastructure that they've created for this therapy and diagnosis system is very much based on the narrative interaction with the person, based on asking them to identify. And another approach that's similar to this, but it's more common, focuses on the somatic memory. So, and this one too, actually, they keep asking the person, where do you feel this or that in the body? And I don't quite understand it, but the idea there is that some pains that some people might have in their backs to have PTSD might be related to their constant attempts to suppress some kind of a traumatic memory that brings the body to a particular state. And the autonomous nervous system is responding in a way just to sort of counteract that. And then they give these ideas about, for instance, how panic attacks are related to this, etc. So what I was trying to, when you were discussing, especially when you were talking to John about the ways that we might basically just create constructions or narratives of the past, I think that when I look at these kinds of therapeutic approaches for many mental illnesses, they seem like they are narrative oriented one way or other. It's basically based on figuring out what kind of narrative is going on and how that narrative can be changed in a way that the person is no longer sort of stuck in those kinds of things, that various kinds of disorders. And it seems like, and some other stuff, other studies I had read that, for instance, depressed patients are sometimes prescribed to watch movies in order to identify with the emotions in those movies. I do wonder whether psychiatric populations, depending on their kind of particular disorder, so if it's anhedonic or if it's PTSD or if it's manic, they must remember the movies differently, or not must, but my guess is that they might encode and remember the movies or the narratives differently. I do wonder whether you know of studies that have done this, that have maybe constructed the RSA or the narrative reconstruction of psychiatric disorders. And what do you think? Do you think that these kinds of things, whether it's in books or movies, do we have a window of studying mental illness in the ways that narrative is constructed or remembered, maybe topics that are more related to their personal issues or not in the movie or such. Do you see a way there? Because it constantly seems to me like there has to be some way to do this kind of controlled wilderness experiments. But yeah, I wanted to hear what you think of that.
I mean, I think there is a lot to be done there. There has not been a lot done with imaging and retelling, like spoken retelling, period. Right. So there's like very few data sets out there where people speak during brain imaging, speaking at length. I think there's a lot of interest in using the movies, though, which, maybe is at least half of what you find interesting there. So certainly like there's a CamCan data set, maybe you're familiar with. So it's this is like a data set where they have a lot of different types of tasks, and there's maybe more than one movie in there. In hundreds and hundreds of subjects across many different, a wide age range, right? So here, like the approach is something like you can say, how do some of these networks and brain responses change over time? How do they correlate with cognitive variables that are changing over time? If you have enough data, can you build a distribution of like the general population? And then if you have clinical group, will you be able to build a population of or either say like how do they deviate from the distribution of the healthy population, like where do they fall on the distribution, or do they actually kind of create their own coherent set, right? I think all of those, like those approaches don't necessarily take advantage of any features of the narrative. That's the thing, right? The only feature of the narrative they're taking advantage of is saying that here we have a stimulus that can actually drive the whole brain. And it can drive some of these parts of the brain that are normally not that interested in responding to, kind of random stream of images. But we're still at the beginning of actually doing this kind of detailed annotation of what's even in the movie, which is the first step to building some kind of model of how a higher level narrative meaning actually might be important for any of these brain responses and how they might be different in various mental disorders. So I guess that's my answer. I think it could be really fruitful, but I don't think that, I think it's only started. I think a lot of people are interested. Yeah.
That's interesting.
Yeah, I definitely want to see more brain imaging during spoken recall. Like we should try to build a narratives data set of that kind of.
Yeah, that's exactly what I was thinking.
Yeah.
The spoken recall is much more interesting to some extent, even because the actual imaging of watching the movie is only interesting for seeing what's maybe being encoded, attention. I mean, it is interesting, but the spoken recall part can tell you a lot about what actually comes up. And I think that what John was saying about, if somebody is pressed, they're going to remember something else. I just wanted to tell John that, interrogators as well as psychotherapists are paid a lot of money to do exactly that. Their job is basically to probe for people to remember something, whether it's for legal purposes and some crime issues, or whether it's for a person's well-being. That's actually it's interesting, come to think of it, like an alien comes to Earth and figures out that some people's jobs is that they're paid to talk to people so they remember the past better. Like that's kind of an interesting thing that there is in our species. So we
remembering the past, like not only veridically, but remembering your own life in a way that makes sense to you. Like that can be the cure. I think that's the idea, right?
Exactly. The veridically,
it's like the Kierkegaard idea, right? You live your life forwards, but you remember it backwards. right? That you always turn it into a story that you're not aware of necessarily at the time you're living it.
Mine is not linearly backwards, it's time hopping. So. As you know, I'm lost in time. So we have a lot of awesome questions, and we were wondering if Andy and Tim might be interested in joining screen. Andy said that he's interested, he doesn't know how, so if Jovo invites him, and also Tim. He says, I'm only on the phone, can try. He's been here on the phone before, but it would be fun to hear the stories. So we have 13 questions for you. Andy Conway, formerly at Princeton, all of us are ex-Princeton, is the highest voted question. So we're very excited to have him up here. And Tim, because he's in a different time zone, he gets
probably and hopefully a little bit drunk.
Yeah, that's I think that's assumed. Hi, Andy. Good to see you.
Oh my God, Andy! Hello, darling.
You haven't changed at all.
Who would have? I never would have expected you to be in one of my visual rooms. We have to get together again.
Well, no, not one of this sort, anyway.
This is really
a
wonderful.
I saw you in a different room the other night.
Shh.
Oh boy.
Hi.
Hi. Hi, everyone. Hi, Janice. Can you hear me okay?
Yeah.
Okay. Janice, great presentation. As you know, I'm a big fan of this whole program of research. I was so fortunate to have a front row seat to all of this because my office was next door to Uri's at Princeton. So my question that I posted was about individual differences, of course, but it relates back to the question about intelligence, right? So, I know at one point somebody like Michael Chow was doing some work on individual differences, trying to relate sort of the traditional
I think
approach.
I'm having some serious connection problems, so I don't know if.
Okay, Ida, can you still hear me?
We can hear you, but you're a little muffled. If you get closer to the microphone, I think there's an echo in the room. You seem to be in a big empty space.
Sorry about that. Well, you can just answer the question that was in the chat then.
Okay, so I'll read the question for you, Janice, if you can hear me better.
Thanks.
Okay, I can't hear Andy at all. So.
Oh, that's sad.
Yeah.
So Andy says, most of what we know about individual differences in cognitive ability, for instance, working memory, is based on tasks that are less narrative-like at both encoding and retrieval. Has your lab or Uri's lab looked into individual differences at all? I know Michael Chow started doing some of that work, but is there anything more recent? Thank you.
I think there's kind of two things here, right? So one is the question of looking at individual differences in narrative memory, right? Just like behaviorally. And maybe the other question is, these intersubject techniques that I'm talking about all kind of rely on the similarity between people's brains. And that leaves out all of the idiosyncrasy. The first thing, I can simply say that, no, I haven't tried to study individual differences in narrative memory performance, but it is something that I think is worthy of doing. I just haven't gotten around to it. The second thing, there's actually a lot of active work that I'm happy to have a chance to talk about. So the way that you can look at individual differences while still making use of these intersubject pattern correlation techniques is with RSA. So they call it intersubject. I think they call it intersubject RSA, and there's a couple examples of this published now. So one place that it appeared first was out of Uri's lab. Mai Nguyen had a paper 2018, and there she showed that if you have people, either listen to a story or watch a movie and then retell it, you can create a similarity matrix based on their speech, like what they said event by event about it. And then that's your prediction matrix for the similarity of their brain patterns during encoding, right? So there you're actually saying, well, pairs of people are similar. What's the structure of pairwise similarity between all of the people? And we've seen that again in papers from Emily Finn and from Luke Chang and Jeremy Manning. So trying to get at, trying to leverage these intersubject techniques while still respecting the idiosyncrasies that could and do definitely exist in the brain signal. So that's, I think, an exciting area, and I expect to see a lot more coming out. I can't, my video is lagging a lot, so I don't know whether you guys are.
We hear
We're all
you. Do you hear me?
Okay, all right, good. My video is
fine.
Yeah, that's great. I don't know if you can hear me great, but Emily Finn's work is really interesting along that line. So a plug for her. Thanks, everyone.
Agreed.
Thanks,
Thank
Andy.
you. Good to see you, Andy. So Janice's, for me, it says waiting for Janice to reconnect. I'm guessing she has internet issues,
It seems like, yeah.
but she will be back shortly. Wow. Baltimore's internet is not very good, is it? We had John's Wi-Fi dropping out, Janice's Wi-Fi dropping out.
I assure you, it's not a Baltimore thing.
Well, I strengthened mine by stealing from all the other Hopkins faculty. That's what happened.
Oh, is it a Hopkins faculty network issue? Like, how are you downloading, John?
Oh, stop it.
John, soon you're
We
just
should hear
going to
from
start
Tim.
doing the salon.
Is Janice
that?
asking to be invited back in?
I'm going to invite her back in, yeah.
Yeah.
How are you, Tim?
Good. Yeah. Quite, yeah. Tired. Lockdown is ending in the UK, and so we're going out to the pub again, and so I'm now tired again.
Wait, you went to the pub?
Some of my two of my lab got married yesterday,
Oh,
So we went
congrats.
out.
I saw it on Twitter.
which was exciting.
I saw, and there was a very nice article associated with that tweet too. That was cool.
Yeah. So
So can we trust that you have drank something already?
no. Well, yeah. Mostly I'm hungover. I got vaccinated though.
Great,
I'm
congrats.
proud of that.
That's
Good idea to
fantastic.
do that before going to the pub.
Yeah.
You know, if you drink a lot of alcohol, they say the antibodies are not going to make themselves. So
Really.
yeah, they say
Yeah.
reduce alcohol consumption a couple of weeks after the vaccination.
I'm pretty sure I got antibodies already. I had COVID a couple of times.
You've had? No.
Yeah. Hey, Janice.
Hi, I'm back. I'm sorry, I don't know what's going on. I just reloaded.
Hey, so thanks for inviting me on. I think it's obviously an amazing body of work, and it's like really inspiring, particularly for people who are trying to look at the same areas with some of those more controlled designs. It just makes you think of things that you should be doing experiments on that you're not. So I mean, thanks for doing that again and again, and great talk. So the thing that so all this narrative stuff has always been impressive, but when I discovered that it worked across individuals, I was like, it totally changed for me what it meant. And maybe you can comment just really again on the scale. And so I know you showed a quick image of the scale of representations that you're looking at, but it's fluctuations over centimeters. It's fluctuations over. You might even argue that it's between one brain area and another. Like, let's imagine that people who've studied those brain areas cytoarchitectonically haven't got the resolution to understand that there's like 5 or 6 different subregions of VMPFC or something like that. Now you're looking at saying maybe one brain area is more active for one scene, and it doesn't seem to me like you're looking at the sort of local patterns of fluctuations that people usually associate with RSA if they're, for example, decoding different orientations of gratings. And so if that's the case, then maybe one of those medial frontal cortex brain areas is, or like medial parietal brain areas is more interested in some particular emotion or some particular kind of agent. And so somehow you can detect the scenes based on the rough content of those scenes. But you're not really understanding but do you think that you're really getting at the representation, which is the construction of the narrative itself, or are you effectively just somehow decoding the rough content of the scenes because one scene's got more emotion than another, more etc. etc. That's kind of what I'm asking. And if that's the case, then maybe that could explain why when you look at the basic similarity between scenes in terms of which individuals are in there or which emotions are in there, you see a much stronger structure than if you look at the really fine-grained causal reasoning behind that was my yeah.
Mm-hmm.
You know what I'm saying. I'll shut up now.
I think that even when you're doing these kinds of RSA or pattern analyses within subject, you still have these questions, right?
Yeah, I totally agree with you. Totally.
So,
agree.
like, there are probably spatially coarse patterns. There are definitely spatially fine patterns, and it turns out that the spatially coarse patterns carry an awful lot of information. I think that's one of the important takeaways from these results. So, you know, it's not really clear to me how, you know, it has yet to be demonstrated that there's like all this fine scale information that like allows much better decoding of moments in movies or anything like this.
So from a methods perspective, that's clearly a major contribution you guys have made. It's changed what people think about what those RSAs are, and also it's pretty clear that that you're right, that maybe an RSA would never pick up that fine-grained stuff. But I think that everyone would believe that if you went and put a Utah array in there, there would be fine-grained information in the cells.
Yeah.
Exactly.
Yeah. I think so. The kind of alternative scenario that you draw, where there are like lots and lots of small patches that go up and down, and each one has like one dimension of the movie that it cares about. I don't like have such a big problem with that scenario. I guess we still need to know what the dimensions are. You know, I guess you could imagine that some of these, you never know like just how big or how fine the correlations are that are driving these, the patterns are that are driving these correlations across a searchlight or across a region.
Don't get me wrong, this is not a criticism. So I think that let's imagine that what comes out of this line of work is it says, look, guys, there are really meaningful, consistent across brains, local small brain area, functionally relevant brain areas that are there in every human at the scale of centimeter. And that's like a profound statement of the kind that Brodmann made. And I mean, do you know what I mean? It's a totally profound, big statement about the organization of cortex. It should, the other thing it should teach all the people with electrodes that their scale, that the micro scale isn't the only scale, and actually they should have 5 or 6 Utah's arrays next to each other to look across the different to look for things across different centimeters. So I'm not in any way minimizing that result, but I'm just trying to understand whether you agree with that or whether, yeah, exactly.
Yeah,
Janice, can I just ask a question just to relate to what he's saying to you, though, is I thought you said at the very beginning of your talk that it had to be a coherent narrative to get the activation of those regions. And I think it was Chris, right, who showed, and forgive me if I'm wrong, sort of a clip where you could scramble the order of it. And presumably that would be an incoherent clip compared, and the pieces that Tim is talking about would still be there.
I don't think that's true. I think that a lot of these, like I mean, I don't know what you think, Janice, but I would think that in those brain regions, you're like if you go and look at Alex Huth and Jack Gallant's map of those kinds of brain regions, it's like the consequence of the narrative is that you feel guilty about this situation or something like that, right? And that consequence is you would never form that consequence. Like, for example, those kinds of emotions and things are in these brain regions, and you'd never form that consequence if you hadn't seen the whole narrative. But nevertheless, I mean, you see the distinction that I'm making. Is it like the consequence of seeing the narrative rather than the process of constructing a narrative?
So can I just make a clarification first on something John said? So John, the scrambledness would bring the representational similarity to the areas of the brain that are only concerned with stimuli, and will take it away out of the areas that were higher level. And so it was no longer the narrative areas, but it was the areas that were visual stimuli or auditory stimuli sensitive. Now, as to what Tim was saying, I'm not sure if there is a very clear area of the brain that processes guilt or other emotions that has been shown the same way that it's been shown for vision. And also, so it's not clear to me why that would relate to that kind of synchrony, unless you think it's just arousal. And if it was just arousal, it should have been the whole brain and not just higher order sort of representation regions. And also a lot of the movies that, for instance, Janice has used, they don't particularly induce that kind of emotions. Maybe some surprise here or there, but the narrative itself, the narrative comprehension of Sherlock doesn't make you feel, it doesn't make me feel anything, to be honest. But so it's not.
It makes me feel awful. Okay.
I don't know. Anyhow, guilt in the audience. That's what I'm trying to say. I don't know if that's a strong argument that guilt is driving, or some one strong emotion is driving everybody's synchrony, and in those very sort of specific high order regions. I'm not sure about that.
Yeah, well, I think it might end up being the case that if there are, you know, features and dimensions that are responsible for organizing the space of these patterns, they're not going to be that easy to put a word on or a label on, and we're going to have to be okay with that, basically.
Exactly.
I totally agree with that. However, I was changed in my understanding of the organization of cortex by the coincidence of your papers and Alex Huth's paper, where Alex Huth's paper finds really consistent small areas in the same part of those brain regions in every individual that refers that exactly respond whenever the story has something like guilt in it, or something like I mean, there is the concept of, I can't remember, but I believe there's one little area up in the parietal lobe there that responds either whenever the word marriage is used or whenever the word jail is used. And like the concept of being trapped, there's a little brain area that responds in every individual for those.
But Tim, aren't those just as meaning saturated as the story itself? And I thought you were making an argument that it was slightly less high order, that what we might be responding to, that it wasn't as you said, I think, the sort of the narrative itself. But if you talk about jail and marriage, I mean, those are saturated with meaning as well, those words.
So here's the question restated. Is there a very, very rich semantic map of knowledge that is what is used to create the narrative, or that is consistent across people? And if so, could you tell that? And that obviously would have no causal. It's just these are the pieces, and that's obviously a very interesting thing in itself. But then that seems to me that if that's what you're getting at that scale, then that would be an explanation for why it doesn't matter whether it's causal or whether it's just whenever I see these parts of the. Anyway. I mean, I've made the point now, so I feel like I should shut up and leave.
But I think that there may be a semantic map. I mean, Alex will be the first one to tell you that he doesn't think that those word embeddings are like the best way to label the map. They just had to be labeled in some way. And you know what the scrambling experiments tell you is that the word marriage doesn't always mean the same thing every time that you see it. It means different things in different contexts. And if you change the prior context, then you're going to change the brain response. So I guess I just don't think that there can be a kind of crystallized map in exactly the way that we've kind of depicted it in this conversation, not like a dictionary. There may be a semantic map that is labeled, the labeling of it would be a lot more complicated than what we have at our disposal right now. But I think that there is a kind of higher level abstract space that maybe, as Ida was saying, there are kind of rules, right? So it's not just like a bag of like random semantic pieces that happen to be activated at this moment in the movie.
You're currently telling what you think must happen, but you're not telling what the data says, right?
Mm-hmm. I'm saying what I think. Yeah. Yeah,
exactly. And so, I mean, everybody I think agrees that that it can't just be a semantic map. There has to be an inference, a complicated inference mechanism there. Everybody agrees with that, a construction mechanism. The question I'm asking is that what you're looking at with fMRI, or are you just looking at the semantic map?
Yeah, that I guess in order to know that, we might have to look at the way that the narratives are constructed, right? Like, can you get to the same place via a different route? Can you have exactly the same kind of recollection of a scene or depiction of a scene, but the process of getting there was different? So you're asking something about like, is it just the case that like any given moment in time, like there's a map that looks like this and that's what you measure? Or is the actual process of constructing a narrative, like extracting it from the movie and then reconstructing in your memory? Is there something else there that is being measured as well? Yeah. And I don't know that we have traction on that.
Thank you.
But it's interesting.
Really. I mean, the whole thing is, it's thought provoking. The whole thing. Thanks very much. I'm going to let somebody else take the stage now.
Thanks, Tim.
Thank you, Tim. I think that you did a good job of explaining at the end. I think that the question whether it's just a semantic map or it's capturing something more, I think that's an interesting one. And relates to something that I asked. It relates to something that I think Janice was saying herself about how to test causal structures, different causal structures, for instance, in narrative, as opposed to just semantic maps. And I think that these kinds of ideas where I think actually, you know what, Tim, I was thinking of even your studies, the one where there's a jumbled sequence and then people have to unjumble it in order to be able to construct a model of it.
We've been trying to look at the similar things from the other angle, from the sort of carefully designed experimental. That's what I mean. We're interested in how to construct a schema. We think that the stuff from the grid cell stuff is relevant as well, and then how you can make a schema of space by integrating all of those different spatial representations. Like you build a schema of a room from boundaries and objects that sit in a room. How do you configure those? I think that building a story is the same process as constructing a scene. I'm hoping that obviously the components are very different, but I'm hoping that the computations are going to end up being the same. And so I totally think that those things are that's why I'm so inspired when I see Janice's work. Yeah, exactly. I'm sorry that I explained it so bad, because I intended to ask the same question all the way throughout that. And so if you only understood at the end, then I'm sorry that I explained it so badly at the start.
Construction of the narrative takes time.
Yeah.
Thank you. Guys. See you. Glad that you got vaccinated.
Thanks, Tim.
So could you please invite Alina, who has the next highly voted question, and also Brad, who has the second highly voted.
Alina does not seem invitable.
They might be. Do you not find their name, or are they gone?
Alina, if you're still here, please let us know in the chat. But we can have Brad. I wonder, while we're waiting for Brad to join, if Ida thinks
I could read Alina's question just because.
Well, let's give her a minute. I could probably text her. I think I have her number. Ida, do you think there's a multi-scale map of semantics in the brain?
I think all of us think that. Is there someone who doesn't think that?
I don't know. Tim's question kind of alluded to he was talking about like the fineness of the scales, which made me think, I wonder if he was saying that there's one particular scale.
I don't think so. I think that for what I know from Tim's conversations over the years, I think he thinks that it's not just a multi-scale map. And sometimes he might actually, he has kind of, we might need to have him back on again if you want to have this conversation. But based on my conversations with Tim, I think he wouldn't be excited when people only talk about multi-scale semantic maps or multi-scale maps. But he also is excited about the particular operations that can happen for compressing them or generating them or sort of creating maps at different scales temporarily based on some basis sets that one might have and some compressed representation that one might have. Tim, I don't know if you're there. Please, say something in the chat if I'm misquoting you. But I think that there is an agreement that you would. Are we getting? No, we're talking about scales in the brain, Tim. That there are multi-scale representations in the brain, but my understanding is that Tim's answer to that is yes and. Okay, he's back.
Hi, sorry, I just walked out for a second, and I thought, and I came back in the middle of Jovo's question. I thought Jovo was asking about the scales of
in the brain.
In the brain, and I think that, and then I thought that Ida, you were answering a question about multi-scale maps where you're talking about different scales of representation of what's in the world. So that's why I asked.
No. How it's represented in the brain, right? So this is what I was saying is that in my conversations with you, Tim, my understanding is that your answer to whether there are multi-scale representations in the brain is yes and the and is that there could be compressed representations with basis sets that can be projected and construct those scales as needed. And they don't need to live there the whole time.
I see. Jovo, just ask your question again quickly. Just I didn't quite catch it. Again, I feel like maybe Janice should be the one taking questions, not me as well. But
well, it's to everybody. I mean, it relates back to what I was saying before. Like, if we have representations, they live in a space, and so is that space multi-scale, and then what is the structure of our ability to represent and manipulate across scales, within scales, and things like that?
Yes, I think that I agree with what. So I think that I think that definitely our representations of the brain are multi-scale and multi-scale. I think that the ability. I sort of agree with Ida again that the interesting question is how can we use those? How can we build representations that can be constructed with that? I feel like that's not. I feel like we understand we understand quite well in neural networks how to build representations that So I feel like I don't have an internal picture. In John's words, I don't have a sort of Sherringtonian chain for how you could take a bunch of representations of individual things and compile them together into a new representation that is the whole, the conjunction of those things. A new representation which is the room. I've got a representation of a TV over here and a cat over there, and I've got to I've got to build a representation of that whole room whereby I can sort of navigate around it. In the same way in the story, I think there's the same issue about the causal understanding of the story. I don't think that everybody, all of us, can say things about what we think would be useful for the components to be. What features of what representational features would be useful for the components? They should be factored away from things. They should be represented in a compressed way where black cats and white cats have many similar parts of the representation, etc., etc. There's many things we can say about the components there. There's nothing I can say at all, I think, about how you construct the thing, the ensemble, from the components. And that's a massively interesting problem, I think. Yeah, exactly.
Cool. Thanks.
Good, Tim.
It's good to have you back, Tim.
Sorry, I am going to go to bed now. Thank you for a brilliant talk, Janice.
See ya.
Thanks.
Hi, Brad. Good to see you. While
Brad.
Brad is asking his question, can you invite Max Ted? He's the next.
Sure.
Hey, it's good to see you again, Janice.
Hi, Brad.
Thanks for the talk.
Good to see you.
Yes, you were describing situation models as being a combination of spatial, temporal, and causal links, and I was wondering if you could expand a little bit on how you see the distinction between, for example, spatial connections versus causal connections. Do you think that is it sort of like a spectrum across those dimensions, or how do you think that maybe the sort of narrative structure might differentiate between, let's see, like a spatial one versus a causal connection?
Differentiate between a spatial and a causal connection. Yeah. I mean, I think of causal connections as being inherently across time, I guess. At least the way that we try to measure them in the narratives, you know, we do it in the crudest possible way, which is we just have people watch the movies and then we ask them which moments in time they think are causally related to each other. You can either do this, you know, we do it just by asking people to pick out the events that they think have a causal relationship. And there's another paper looking at this by Song. There's a preprint out where they do a pairwise. They give pairs of events to people and ask, how much do you think there's a causal relationship here, right? So that's how you build that causal network. So I guess the space is a feature that doesn't necessarily have to span time, right? It can just be a feature of the current moment. So are you thinking of them as being somehow, well, how are you thinking about their relationship to each other?
What I was wondering is whether or not narrative might be composed, you know, if we're trying to sort of think of like, what is the special meat of being narrative, like those kinds of relationships, are they primarily causal, or is it possible for there to be a blending of causal and sort of, I guess, raw sensory information, such as temporal sequence and spatial information as well?
Mm-hmm. I don't think they're purely anything. Yeah, I mean, well, we don't know, first of all. We, in terms of like what features in a stimulus will drive activity in these regions in a reliable way across people, I think all of those things probably contribute, right? But I wouldn't want to be in the business of saying, can I strip away everything except for one feature, and is that still going to be a narrative? Mm-hmm. I think some of the one of the people that I cited, like on my first slide, I think in the narratology literature, there's a kind of nice approach to this where they list a bunch of things that could be in a narrative, that could like help define a narrative and make something a narrative, and then you may be more, your stimulus or your series of words may be more narrative, like if it has more and more of those things. So there's a kind of spectrum of narrativeness. That's the kind of that's kind of where I'm at in thinking about it.
Mm-hmm. Yeah. So as I was thinking about this, I was thinking more about sort of the way that causality is perceived in a narrative is different than the way that we think of causality as being perceived, perhaps from learning about statistical regularities in the world, or through manipulating things, right? Like there's something about narrative context that allows us to perceive causal links, despite a kind of lack of evidence that that the brain would normally require of sort of inferring causality from just like, interacting with this object, for example, dropping it, moving things, right?
Yeah. It definitely has to draw on your knowledge of the world.
It's just that I've still been sort of wrestling with this idea of what constitutes meaning in narrative, and I think that causality is certainly a key part of that. Anyway, thanks a lot. That's really interesting.
Yeah, thanks, Fred. Food for thought.
Thanks, Brad. Nice seeing you. Next it.
Go ahead.
Sorry, I seem to be having a few issues with my camera and my microphone. Thank you again. It's always such an interesting discussion. I've been sitting here and my brain's been exploding. So thank you very much as always. I think my question has largely been answered by some of the conversations you had with John and Tim, and then some of the things in the chat as well. But one of the things that I was thinking is, how do you think that some of those representations that you saw in the brain would change if clips weren't novel? So for example, if everyone saw the same clip, duration between clips were then controlled for, do you think that the different appraisals of the content of the scene, so whether or not people like them or the things that were salient for them, do you think that would impact like maybe subsequent recall and brain activity on that?
Sorry, you're saying that if people's if the clips aren't novel and they see the same clips over and over again, how do the representations change with repeated exposures?
Yeah, so or I was thinking more around like more like divisive content, which is why I was interested in what John was saying about or the paper that John originally talked about Alfred Hitchcock, where they had like, you know, it was Psycho and things like that. So for example, if different people watch different different people watch the same clip, appraised it in a slightly different way, and then rewatched it later, do you think that the representation would change?
I definitely think the representations would change. I mean, I can tell you what we have done in this space. So there is the movies are the most powerful when they're novel in terms of synchrony across people in a group. And I think it's because they're designed to be seen for the first time, right? They're not necessarily designed to be seen for a second and a third and a fourth time. It's not only boredom, I guess. So one thing is that it's often, you know, if you show a clip many, many times, then you're going to be dealing with fatigue as a confound. But also you're dealing with the fact that people remember the time before, and that changes how they perceive it the second time. The story isn't designed to be perceived a second time, so it's less good at generating the same representations or comprehension in multiple people. I think, you know, you might still have I like to watch reruns, so you definitely can still engage with the story the second time or the 100th time, but it won't be as stereotyped across people. So when we show people the same movie twice, the first time is the strongest synchrony, the second time will be less good. And we've also, Miriam Ali has a study where she shows people clips like 6 times, I think, or 8 times. You really see the inner subject synchrony drop dramatically after the first time. So that's just like what we see. That I think puts a bit of a damper on ever using a lot of repetitions in this kind of work, because your signal just starts to go down, the signal of what's shared across people. But, you know, as far as like reappraisal, I think that the study I mentioned, the Yeshurun study, where you have different people who have different understanding of what's going on in the story, even though they're receiving exactly the same story. I think that shows you that if you reappraise a story that you've already encountered and then experience it again or exposed to it again, if your understanding of it is different, then you should have a detectable difference in neural response in these regions to it. So that's what I would predict modulo all of the signal loss when you show movies over and over.
That's really interesting. Thank you. Do you think that you could maybe almost drive people to confabulate different narratives depending on different maybe questions or follow-ups and things like that after someone had watched the film, and then you gave them a different set of questions afterwards? So for example, I don't know, asking about a particular stimuli. I'm thinking about John's windows are all open in the room across the street. Do you think you could almost make people confabulate and create different narratives depending on the questions you could ask?
Yeah,
after
there's some so there's the old psych experiment that has been kind of revitalized in modern paradigms. I think, Ida, you used this one, right? Where you have people read a story of like walking through a house, and then later when they recall it, they have to take different perspectives. They're either, now you're the perspective of like a home buyer, or now remember it from the perspective of a burglar. And it changes what you remember about the story, right? So there's Aseh Zabrud has a study still unpublished, but coming out soon, I hope, where people, it's a movie with a twist ending. And so you have people who do get to see the twist ending, or people who just watch it and they don't get to see the end. And so when people recall it, of course, their memory and their retelling of the story is quite different if they have a twist ending that has changed how they might think about and understand each scene of the movie. Those kinds of changes in interpretation are definitely detectable in these brain regions.
One thing I wanted to say is that something that we did with that story where you're going through a house is that it's not just that every individual remembered alone, but we had people talk to each other in networks. I think Max said if you mute yourself, we wouldn't hear the echo. Thank you. So the Jovo muted you, so that's okay. So the people talk to each other in different networks or constellations. So for instance, and they didn't know who they're talking to or what the constellation or the network is, but a chat window would open up, you talk to someone, another chat window opens up, another chat window. Unbeknownst to you, the network is actually of 16 people, and you're either in a situation where the bridge ties in the network are talking first, or the bridge ties are talking last. And in that case, we see more convergence or more memory convergence among the entire network and within clusters when bridge ties talk to each other first. So that's just a behavioral study, and it's based on the idea of collective memory. And if we thought that if we give a story that it has different kinds of ways of remembering, depending on what context they remembered, there would be a division of what they remember from that story. And I think that that was the basis, in fact, of the meeting that I was remembering that we had, and Bo was providing that movie that Nicole Kidman was in, where they wanted to not only have people watch stories and remember, but have them talk to each other and see how they synchronize with each other, which is another interesting aspect. Hi, we're so happy your computer finally works. Do you want to go ahead and ask your question?
Yes.
I can't hear if there's a question being asked. Maybe it's the same problem I had before.
So you might need to increase the volume. Their volume is a little low.
It just sounds like all audio cuts out when you start talking. I think it actually is a problem on my side.
Oh,
Go ahead.
Yeah.
Okay. Well, I will ask. Can you hear me? But if not, okay. So my question was related, somewhat with the Necker cube storytelling or that something.
I can't hear. Sorry.
Maybe if somebody on the stage can ask my question instead, that might be simpler.
I can hear you perfectly, but okay, I can read your question, but stay on screen so you can have your follow-up. So now I'd like to ask everyone to mute because I hear my own echo now. Maybe Jovo can handle that, actually. So okay, here it is. Is the same story, if the same story was told from different perspectives, do you expect the brain activity to be as well synchronized as watching a movie vs listening to a narrative of it? Or will it be different as the meaning of a given moment becomes different to different characters? So the idea would be that the same story has different narrators, and there's different meanings depending on which narrator, I guess, you might identify with, if I understand correctly, or with, okay, yeah. So if you identify with John versus me, you might get a completely different story of what happened.
Yeah, maybe.
Can Janice unmute herself? Jovo, did you mute her in a way that she can't? Okay, good. Go on, Janice.
Janice?
Am I unmuted?
Yeah,
Yeah.
but now you muted yourself again. Still muted. And
I'm
Kohler,
trying to unmute you.
you're muted for some reason. Oh, now you're
Mhm.
unmuted. Now you're unmuted.
I'm unmuted again. Sorry. Okay.
Just don't
Can you hear
touch-
me?
Yes.
I think that the brain activity is going to track the meaning and the interpretation of the listener, right? So if the story is being told from by a different narrator or from a different perspective, then the brain activity is going to reflect that perspective. But if the exact same perspective is being delivered in a totally different modality, like that will be invariant. The response will be invariant to that. That's the prediction. And again, the Yesharun paper, I think, kind of shows that different interpretations, different. So there, it's not the perspectives. It is the perspectives of the characters actually that's changing, because what's happening in that story is you either think that there's like a cheating situation where like a woman is cheating on her husband, or you think that the husband is just paranoid and she's not cheating. And so the motives and the understandings of the perspectives of the characters are pretty different depending on what you think is really going on. Yeah. Did that answer the question? Sorry. There were a lot of gaps for me.
We have a number of other questions, but Alina's, for some reason, also their Wi-Fi doesn't work very well. So I'm just going to read their question as well.
Okay.
Alina asks, thank you so much. It was so great to see you, and thank you for asking your question. Are the time frames of synchronization different between different cortices? What are the time scale synchronization to what level of elementary stimuli?
Am I here? Okay. So different brain areas have different intrinsic timescales, and it's just possible for some of them to synchronize more quickly than others. Chris Honey just had a paper on this, looking at different brain areas across the cortical hierarchy and how quickly they synchronize, actually. So I would suggest taking a look at that. That's in Neuron. Chen is the first author. And there, basically, low-level sensory areas fluctuate more quickly, and they're capable of changing more quickly. And high-level areas like these default network regions that we're talking about, they fluctuate very slowly relative to the sensory areas. So they tend to align more slowly too. This might be like this property of being slow might actually be part of how they are sensitive to context in a stimulus like a narrative, though. So I don't think it's like an accident, but that's the answer to that question. I think as you go from early stages of cortical processing up to the highest, most abstract kind of information, it gets slower and slower and slower.
Awesome. I was trying to hand gesture where these areas are because John Rusky asks, sign languages are known to be highly iconic, meaning their words and narratives form kind of the linguistic middle ground to what you've looked at here. Would you expect any different behavior in signers?
Oh, wow. I think I just don't know enough about what you mean by middle ground in order to be able to answer that question. To the extent that you're able to use that language to depict the same situation and the same events in the story, I guess I don't expect there to be any differences, but that would be a really interesting thing to try to study, to deliver the same story in sign language and auditorily, I guess, to a hearing population and see what the corresponding the correspondence is. Marina Bedney has these experiments using stories in the congenitally blind and looking to see where some of these representations that we think of as being very high level actually may have reorganized and are present in visual cortex now. So I recommend checking that stuff out. There could be a similar thing going on in signers.
That sounds very cool. Maybe one final question. Sarah Solomon asks, does the abstract structure of narratives affect the encoding or retrieval of new narratives? I'm thinking of a structure transfer situation in which encoding a story with one narrative arc would make it easier to encode a second story with a similar narrative arc, or potentially make it difficult for a different one. Pushing further, does the consumption of narratives and their internal structures lead to impose narrative structures on the events in our own lives in an attempt to understand or compress our own experiences?
Yes, and yes, I think. I've considered narrative structure priming experiments like that before. I don't know exactly how to conduct them, but you can feel it in your own consumption of narratives, right? Like if you I watched some kind of like cheesy like romance movie the other day, not the kind of thing I normally watch, but Chris wanted to watch it. And there was some point at which
Chris under the bus.
Yeah, I mean, there's only like 15 minutes left in the movie. And I was like, how is the couple going to break up and get back together in this amount of time? Because that's what's going to happen. So like you have these strong kind of, if not latent, like either latent or explicit knowledge about how certain kinds of stories are supposed to go. And especially if it's Hollywood, you have the right kind of context for making a prediction about what the narrative structure is going to be like. So I think that if you created a type of narrative structure that maybe wasn't common, but you taught it to people, then you definitely should be able to see them come to expect it. It's like any other sequence that you teach people. And there are families of those types of different narrative structures that we are familiar with through our cultural experience. And I think that we probably do try to put our lives into those structures too, for better or for worse. At least it probably helps you remember them. Maybe not veridically, but it helps you feel like you're remembering something.
I like what you're saying. In fact, Jean-Luc Godard had this idea that, again, one of those people who makes long movies that many people are like, what happened? And I'm like, oh, this was such a great movie. He used to think that Hollywood movies are all predictable. And he had like there was this whole idea that there is like a matrix to it and you can just always predict. And immediately when you said, how does a couple like break up and get back together? And I was like, it's either going to go back in rain and look at the window or like something similar, some kind of a situation. There's like a very clear template that it's very interesting that in spite of the fact that that template is very predictable, people really like it to be repeated over and over again. It's a little bit, to be honest, it's like a cultural OCD. Like people like it's like cultural narrative hand washing over and over and over again.
Yeah, I actually I am really disappointed by it. Actually, like when I watch a movie like that, in the last half hour, I'm always praying like, please do something different and interesting. I want to see like everyone like move to a different country, or like it turns out that aliens land. Like just give me a different ending, but usually you don't get that. Yeah.
That's interesting. Yeah, I don't, but I have this Joseph Campbell book. And so this idea of hero's journey, where there is there's always a 9-step kind of a story, and it has particular parts to the narrative. I do wonder whether we can start thinking about experiments around that, whether you have that kind of a hero's journey narrative or you have another kind, and then you compare. It was interesting to me because in that story, there is another book called Heroine's Narrative. So it's about women, because that one is always the journey of a guy, and there's always some kind of a return to some father figure or such. There's always some kind of a Yoda that helps him along the way, and he finds a purpose, whatever, goes back home, a whole newfound person. This narrative is so overtold. Currently, N.K. Jemisin, one of my favorite science fiction writers of all time, she has a masterclass on Masterclass, the app, on science fiction writing. And something that she says is, please just forget the rugged individual narrative. Kind of the person who doesn't need people and goes and And it's interesting to me that there is all this kind of other forms of narrative, and now especially when we're thinking about reading women or reading people of color, and the stories are kind of different. So some of the structures are different. And in fact, there was a critical theory analysis comparison of hero's journey of Campbell versus heroine's journey. Like, what is the sort of the parallel for women's stories? And it also reminds me of something that Virginia Woolf said in her diaries, that she had read a book as a manuscript because she was the editor, and then she didn't like it as in terms of literary merit, but then it stuck with her so much that she had to go back to it, and she thought, why am I stuck with this? She realizes that there is a friendship between two women that has nothing to do with men. It's just about their own friendship, and how rare that is in literature. And then she writes in her diaries that for thousands of years, the stories of women's relationship has been told by men, and therefore it's either somebody's mother, somebody's wife, and the other person wants this person, somebody's daughter. There's always some man as an intermediate of these relationships, because that's how men had experienced the relationship between women. And then she was so shocked that now all of a sudden there was this narrative of a friendship between two women that had no men involved in it at all. And so it would be very interesting at some point to be able to take a look at these nuances, just behaviorally. Not necessarily, I'm not as much interested in this one on a kind of a functional neuroimaging analysis, but behaviorally, I would love to see how different people kind of respond to these different types of narrative, whether it's for narrative priming, because it could be that if you're narratively primed with the hero's journey, you're going to look for a man in a woman's sort of journey. But if you're primed with a witch story, maybe you don't look for that at all when you hear another story about a woman. So that's kind of been always very interesting to me in this.
Yeah, I would love to see, to just be able to map out the different spaces of narrative structures that exist in the world, and to kind of know what our narrative diet is. What my own diet is and how it changes over time. I don't know of any way to do that right now, but text analysis is getting very, very easy. So maybe there will be a big data way to basically say, here's your information stream, and you spend all day in front of the computer anyway. Here are the classes of narratives and the proportions of them that you actually are receiving. It could be really cool.
Very cool. You just need people's Netflix accounts, Amazon Prime accounts, Hulu accounts. Just gonna yeah. So I love what you're saying. So the idea would be very much the next level of the current NLP embedding models, which is the narrative structure embeddings of people. What kind of narratives are people embedded in?
Yep.
As someone who has lived in 4 different cultures with 4 different languages, I can very easily see that the template for particular things, for particular narratives, are very different in these cultures, and what's in common, what's more similar across some of them. It would be absolutely very interesting to look at that.
Does Princeton and New York City count as 2 different cultures? Out of curiosity.
Oh, I have in mind Iran, the Netherlands, Germany, and the United States.
I see.
Yeah. but it's true that Princeton and New Jersey have different cultures. So maybe I should have counted 5 instead of suburbia versus big city. So there are more questions, but it's already 20 past 6 and John had to leave, and you have done a fantastic job. I feel like we are on a high note. Some of the things that I really appreciated was the potential to perhaps, in our conversations, was the potential to just look at somebody's brain data and look at complete other strangers' annotations of a movie and figure out whether this, or predict this person's comprehension or retrieval of that same story. And I particularly love this idea that it might be possible to do narrative priming, or it might be possible to these kinds of embedding of people's narrative structures. That sounds revolutionary to me. Like, if that happens, I feel like something will change in how we look at the world.
Yeah, it's a really interesting discussion. Yeah, after this, I need to spend some time trying to jot down everything that happened, so I make sure to retain all of the pointers. Yeah.
Jovo, any favorite moments? Any famous last words?
I really like Tim's drunken stupor. No, but Janice, it was really fun. You know, it's always great talking to you. I'm so grateful that during non-pandemic times, if I want to see you, I can just walk across the quad and talk. And I'm looking forward to being able to do that more in the future.
Yeah, me too.
I also just want to thank everybody who's behind the scenes. Especially, I want to thank Bahar, and I want to thank Claire. Claire and Bahar have been holding it together while other behind the scene folks are a little bit on sabbatical right now. Or potentially, like, you know, off to better things. Like Brad is retired because Brad is now organizing the Neuromatch Academy, so he's very busy with that.
Oh, that reminds me, people should be applying for TAing and joining the Neuromatch Academy specifically for deep learning. I'm partially teaching one of the days, and there's a lot of other fantastic speakers and organizers.
Yeah, and there is a $1,500 for TAs for the deep learning, as far as I know. So if anybody is a student or postdoc and would like to make some money and TA at a fun event, that's a good place to go. Thank you so much. I hope that we see each other soon in person. I really miss you personally, and really hope
you
to
too, Ida. Hope we can watch a movie together again someday.
Oh. Maybe a romantic movie with Chris.
Only if the world explodes at the end.
Oh my God. All right. Take care.
Thanks, guys. This was so fun. Thank you.
Thanks, Janice. Have a great weekend.